Section 1.6, Linear Inequalities. We use inequalities when we just want to be above a certain value or below a certain value, or within a range of values. An easy example is to think about grades in school. If you want an A, then you have to earn at least a 90% in the class, meaning that you want your grade, we'll let G equal your grade in the class, to be greater than or equal to 90. If you want a B, then your grade needs to be greater than or equal to 80, but less than 90. And those are two examples of inequalities. This first one we just call an inequality. The second one we call a compound inequality, because we are bound on both sides, both a less than and a greater than. When solving inequalities, what happens is we get a set of possible solutions, which we can graph on a number line and express using interval notation. This is very different from the single solution that we get with most linear equations. For example, we can look at 5x is greater than 25 versus 5x equals 25. With 5x greater than 25, we divide both sides by 5 and discover that x must be greater than 5. However, with 5x equals 25, x just equals 5. For the inequality, we can sketch a number line. We use an open dot or a parentheses at the 5. And then we shade in the number line that goes greater than 5. And everything gets erased. There we go. You can also use the open dot method, where we see an open circle. The circle would be closed if it was possible for x to also equal 5. And we can express this in interval notation, saying that x can be anywhere from 5 to infinity. This is very different from the equation, where x can only equal 5. So we'll have a single dot at 5. Or we can express it using brackets, expressing that our solution is the number 5. When we solve inequalities in general, it is very similar to solving equations. The one thing you must remember is what happens when we multiply or divide both sides by a negative. For example, we know if we have negative x is greater than 2, well, that means we want to be at least 2 values up from 0. So this is what we want to have happen. But we want these to be the values of negative x, meaning the values of x that will result in this are everything less than negative 2. Because when we multiply those values by a negative sign, it flips them, putting them into this spot on the graph. Thus, the upshot of this is whenever we multiply or divide by a negative, we need to switch the inequality sign. So negative x is greater than 2 means x is less than negative 2. Try this example in your notes and go on to the next video when you're ready to see it.